Hello students, so in this video we'll be talking about negative selection, when it's used, why it's used, and how all this is useful to you in the Aptamers lab. But before I do that, let's start talking about something a little bit more common that's related to negative selection, and that would be positive selection. So, positive selection in this lab, as you all know, is the immobilization of desired binding species onto your beads and removal of the non-binding species. So I'm going to go ahead and draw this here. Let's have a nice little blue tube and maybe some blue beads scattered around in the tube. And let's pick a color for the binding species. Let's make that pink. Alright. And the non-binding species will be the red color. That sounds good. So, in our lab, we add all the species before we know what is bindable and what is not bindable in this lab into the tube. And we go ahead and mix them all up in there, and they get into the tube. As you can see, I'm drawing them bound to the beads. Let me draw the other ones. And let's go ahead and shake that up. These lines are shake it up lines. And what happens after this, as you all know, is we elute the non-binding species as they will not have bound. So let's draw some more beads in there. Get the good binding species that we want in there. That's real nice. And the non-binders, and those are being poured out. That's what we do with them. Just have a bunch of nice little squigglies there and a nice little arrow. So following this, let's go on to negative selection. As contrasted with positive selection, negative selection is the immobilization of the undesired product this time. So let's go ahead and show you how we do that. Let's draw the blue tube and have all the product mixed up in there. Same thing as before. Let's make the desired product the pink squigglies and the undesired ones the red squigglies. So, as before, we go ahead and mix it all up in there, and let's draw a nice little arrow. And this time, when we pour out from the tube, we'll go ahead and pour out the desired product and save that. Let me go ahead and draw that for you though. Pink squigglies this time are being poured out and decanted from the tube, whereas the red squigglies are now staying inside the tube this time. And with negative selection, what happens is we would go ahead and save the pink squigglies, and let me see if we can show you what would happen with this other stuff. Alright, so this other stuff, all the undesired product, will go, let me see, to the trash. Yes, there we go. Sorry, I'm not a great speller. So yes, that's the difference. In positive selection, all the stuff that stays in your tube will be what you want, whereas negative selection, all the stuff that stays in your tube is what we don't want. But let me get into why we do this. So let's start off with, well, two reasons really. One reason is that species will bind to the tube, and let me go ahead and draw that here as I am showing you the pink squigglies are not sticking to the side of our tubes, but the red are. The red are binding species that just happen to stick to the tube for one reason or another, and they do that round after round and will get amplified. Some RNA product will also bind to the beads. Let me go ahead and draw that here. It's our tube. Let me draw a nice big bead because this will take a close-up. And something I didn't draw before are the proteins that we bind to the beads. So usually the RNA product that